Alright, so let's start making the chip. I already made it. I think it's 99.9% done. The only thing left is I need to add the PWells and NWells to cover all the areas. So let me open that chip layout for you right now, and you can see that I don't have many other components to be included in the chip. So what I have is an inverter and op-amp, and that's it. So this is a newer version compared to the version on the tutorial. You can find out over there. The difference is I have a ESD protection ring across to wrap up all the chip area. So this is a standard way to make it. If you see look at the previous version, there's nothing, right? So it's just bare pads, which is not really good because you do need something to protect your components inside the chip. Okay, so that's the chip layout, that's the chip schematic, and we are going to start from scratch and redo everything for you guys, just in case you are having some problem when you are doing the layout. All right, so the first step is to make all these ESD protection diodes. So that's a single diode. You can see I make a diode over here, and a schematic come with it. And there is a pad. So that's a diode itself. So this is not a pad. And I use this one as a package in the pad layout and schematic. You can see here's a pad for this newer version, and that's a pad layout. You can see this is a little cap. There's a diode over here, another diode, and all the metal wires. And here's the schematic for the pad. Here's the icon for the pad. So after you have the pad, you want to make a pad frame. So just put all the pads together to make a chip, 1.5 by 1.5 millimeters in size. And the same for the schematics. So use the icon over here to make up this schematic for the chip. And that's a top version. That's a top view, very top view. And if you go down, you can see under this view, under this hierarchy or level, there are the next one is a pad analog _analog is this guy. Okay, and under this one is a pad is a diode, NAct PWell diode and PAct NWell diode. And I think that's it. So this pad frame is made over here. You can reuse it for any other projects. So that's why I'm not actually put everything over here. So I'm using this one in my chip view. If you go to here, I directly drag this pad frame layout over here and drag my inverter from here, not the simulation, from here, and then drag my op-amp, which is this guy, right? This one, just drag it and place this one to here and make all the connections. So that's a procedure to make this work. And I will probably, I don't know how many videos I'm gonna create from this to do this, but maybe 4 or 5, probably. So the first one, we're going to focus on making the ESD diode first. So this one and this one. Okay, so now let's get started. So the concept for this guy is, you can see, let's take an example of this one. All right, so here's a wire. So this wire will be connected to the pad, the metal of the pad, and then the any signal is going to comes into this area from this metal wire. This is metal one, since it's a blue color. So this one right here is, so NAct is being connected to the N. What is this? What is this part? This is the N act. So it's going to be this node, right? So you want to grab one of this and resize it to this size, which is 50 by 50, and make a connection. And also click this one, make a port, and N plus, if you want to form a diode, N plus is the bar of the diode, right? And then you need a P. So because N plus is directly being fabricated on the P substrate, and we're going to draw it for you, draw the cross-sectional view for you guys so you are understanding this better. And then you need a PWell. It's actually the P substrate connector. It's just a connector. Okay, you are connecting. So actually the this is a P side anode of the diode, and this is a cathode of the diode. And how that works? Now let's draw it, so you can get a concept about this one. So remember, we have a metal one. That's a metal one, and here is the NAct, right? Let's just do it quickly. This is NAct. And then we need a ring of PWell connectors. Why do we make a ring here? Because we hope all the electrons are being constrained in this region. If you look at the, so this is the top view, right? If you look at the cross-sectional view, you will find out. So that's N plus, and that's a P, the connector of the P substrates. Connector of P sub. If you look at this is page 1. Let's label this first. If you look at the cross-sectional view, it is actually something like this. So this area is a N plus, because NAct is a N plus being directly fabricated in the P sub, right? So that you need an NAct, and that's NAct. And then this ring of P substrate connectors, they are actually a P plus being directly fabricated in the P sub. And if you cut it from here, you are going to see something like this. So this is top view. This is a cross-sectional view. Cross-sectional view. If you cut it, you can imagine that this is a P sub, P plus, and that's an N plus, right? So this is what that is going to look like. And you can imagine that this one, if you go inside the paper, it's going to be a line, and the same as when you go outside of the paper, you are going to see a line as well. So they will be connected. It's going to be connected to here, right? This is a ring. And in that case, it's a diode, but in a weird shape. It's not ideal like this. It's not real, right? In the real life, it's hard to make a pin junction like this. So, but in the CMOS fabrication facility we have, this is, it's going to be a diode, because the ring here, the P plus ring, will be this node, and the middle one will be this node. So you are actually forming a diode over here, and you get a metal contact, which is this part, this guy, right? So this guy, and you get a metal contact, which is this guy, this part. All right. Hopefully this is clear. It's the same concept as so this is NAct and PWell. Diode. All right. So now let's save it. One. And the same concept for this. And this is a P plus, and you need a ring here. Since you hope you can write up all these electrons communicating with this P plus. All right, and this is PAct because this is P plus, and this is a NWell, and it looks like this, right? So the diode looks like this, and if you this is top view, and the cross-sectional view looks like this. If you cut from here, you are going to see a P plus, right? Make a P plus. So P plus is a P material being directly fabricated in the NWell. Okay, so P plus and being surrounded by NWell, PAct. So that's a PAct, and you need NWell to surround it. So actually, everything is being fabricated in NWell. Why? Because you don't want the P substrate, the P plus being shorted to the ground, right? So everything is fabricated in the NWell, and this is the NWell connector, and they are being shorted together because it's a circle, right? And this is a P plus PAct, so it performs like a diode in this way. Okay, I think this is clear. So now the only thing we need to do is just make it work, right? So I'm going to save this guy to, and let's build it in here. So I already have it, but I do not want to just give the example to you. I want to build it on my own, so you know how that works, how you can make it from scratch. So let's do it here. Let's create a new cell, and I'm going to delete it after I'm done, since I don't need it. So I will call it. Let's start from the layout. I'll call it test NAct PWell. Right. So that's the test NAct PWell. And now let's look at the dimensions for everything. So this is 50 by 50, and this is 30 by 10. So let's come back here, and since the NAct, so we need an NAct, and it's 50 by 50, and the origin is 0, 0, and 30 by 10, which is a PWell, PWell. So this one, you can see that I have 3010, and I have 8010, and I have 6810, right? So now let's make all these bars. First one, it's 8010. I need 2 of them, right? And I also need 3010, 2 3010s. And I also need a 6810. 6810. Right, so all these bars. And let's assemble them together and see how that works. So the distance between, so we need to rotate it first, right? Same here. Rotate it. And you need this bar over here. So this one need to be as close as it should be. Make it here. All right, so make sure they are in the same line. And then you can move it closer to this. Same here. As long as they have this PWell, which is the slashes, as long as they got overlapped with the previous one, the NWell's, the NAct PWell, which is good enough. And make sure the contact points are not too close to each other. All right, and then you got you need two of these ones. So put it here for the first one, and this to here, and move it down. Move it down. All right, further, because you want to make these slashes overlap with this slash. All right. I think that's it. Let's F5. You see errors because these are being overlapped but not being connected. You want to single click and then right click to make the connection, right? And F5 again, still errors. What are they? So these things are, seems like they are not totally overlapped. So I just push the downward, the down arrow again, and I think it should be fine now. So F5, no errors, is DRC clean. See DRC clean. So that's pretty good. And now we are making a metal wire. So you want to go here, do this, and make a node first, and connect it to here. And you can redefine the width. Let's make it 10. And same here, right? So you single click, left click, and export it. Let's call it PWell. And press Control when you are trying to select this text and you want to make it larger. So let's pick up 10, for example, as a PWell. That's a export, right? And the same here, you need to find out this node and Control click. So you can pick up the node and Control E and do a NAct. Right, and Control click, click. So it's been selected, and then go here and do 10, change the size, and you are done with this diode. I5 is DRC clean. So that's for this NAct and PWell diode. So what about the, yeah, you need to make a schematic out of it. Just doing a good practice. So let's just do it right away. Do not wait until very late. So you just don't want to do it anymore. So test, you want to keep the name consistent, right? NAct and PWell. So you are doing a schematic for now. Schematic. The schematic, this is a, did I do a schematic? Yes, I did a schematic. So you just draw it, right? Just draw it. So these are the wires and you need a node. So let's draw the same stuff here as whatever we had. So go to components and pick up artwork. And then since you want to draw a triangle here and put it at the origin, right? And then you need a bar. So the bar is a line, and you want to press Y, the Y letter on the keyboard, so you can edit this line and just make it into a line. This is a weird, I know, but this is how that works. And make it into a line. Make this guy into a line. And make it shorter. make it shorter, and put it here. And you need another line. Okay. Yeah, actually this line needs to be shorter as well, right? Press Y again so you can add it. This line. Yeah, it's a little bit weird. And you just wanna do this again. Control V, and put it here. It's not being aligned to each other. So shift click. All right. So it's because the grid is too big. Let's use the smallest one. Let's see if that will work. Still not. All right. I hope this can be at 0, 0. All right, 0, 0. And this should be at 0, 0 as well. 0, 0. And this one, let's do 0, 0. And now let's split this guy, all these guys. Here, here, and this guy over here. Yeah, let's just keep it like this. And now we need a export as well. So we need to find out the node export. So pick it up, Control E, and this is PWell. See if we can make it. So we made it. And this is, no, this is not PWell. This is actually NAct, right? So NAct. And this one, let's make it PWell. Right, and save. And now let's see if this will work. So F5, no DRC errors, L. So schematic and the LVS matches as well. But the concern is, I don't know if we really can use it, right? Because here, do we have a diode here? There's no diode. Components, do we have a diode? So since there's no diode, oh, there's a diode actually. I think we should use this one. If we use this one, oh, let's try it. If we use this one, let's put it diode area. I don't know. We don't know. I don't know if we need to model that. But anyway, let's just get a wire out of it and see if we can directly do LVS. If LVS passes, I think we are fine. So export file, this should be NAct, and this one should be PWell. So now let's do LVS. It works. So I think this is fine. Let's just keep using this guy. So it's the same concept as if you do another one, test PWell NAct, right? So it's going to be the same concept. I don't think that should take too long to make that one as well, make that work as well. It's going to take a lot of time. So let's just stop here. So you will work on the test. You don't want to use test, right? It's going to be your library since I want to differentiate from my own libraries. So you can directly do a PAct and NWell, right? All right. So let's see you in the next video.